It is not safe to connect an air conditioning unit with a minimum circuit amp rating of 32 amps and a minimum breaker rating of 50 amps to number 10 THHN wire. Number 10 THHN wire has a maximum ampacity of 30 amps for continuous use. The air conditioning unit requires a minimum circuit amp rating of 32 amps. According to the National Electrical Code, the ampacity of the circuit wiring must be at least equal to the minimum circuit amp rating of the load, which is the air conditioning unit in this case. Therefore, number 10 THHN wire is not suitable for use with this air conditioning unit because its ampacity, which is 30 amps, is less than the minimum circuit amp rating, which is 32 amps, required by the unit. Using wire with insufficient ampacity can lead to overheating and damage to the wire and components in electrical fires. You should use number 8 THHN wire or larger, which has an ampacity of 40 amps or more and is suitable for use with this air conditioning unit. When selecting wiring for electrical circuits, it is crucial to adhere to the National Electrical Code, also known as the NEC, and local electrical codes to ensure safety and prevent electrical hazards. The NEC provides guidelines for the proper sizing of conductors, overcurrent protection devices such as circuit breakers and fuses, and other electrical components based on the anticipated load and operating conditions. The ampacity of a conductor is defined as the maximum amount of electrical current, measured in amps, that a conductor can carry continuously under specific conditions without exceeding its temperature rating. The ampacity of a conductor is influenced by several factors, including the conductor's material, size, insulation type, and the ambient temperature in which it is installed. THHN wire is a common type of built-in wire used in residential, commercial, and industrial applications. THHN stands for thermoplastic high heat resistant nylon coated. THHN wire is known for its heat resistance, moisture resistance, and durability, making it suitable for a wide range of wiring applications. The ampacity of THHN wire varies depending on its size, which is expressed in American wire gauge, or AUG. Larger gauge numbers indicate smaller wire sizes, while smaller gauge numbers indicate larger wire sizes. For example, number 10 AWG THHN wire has a lower ampacity than number 8 AWG THHN wire. When selecting THHN wire for a specific application, it is essential to consult the NEC and the wire manufacturer's specifications to determine the appropriate ampacity for the intended load. The minimum circuit ampacity, also known as the MCA, is the minimum current carrying capacity required for the circuit conductors that supply power to the equipment. The minimum circuit ampacity is determined by the nameplate rating of the equipment, which specifies the maximum current that the equipment is designed to draw under normal operating conditions. The MCA is used to select the appropriate size of conductors for the circuit to ensure that they can safely carry the anticipated load without overheating or causing voltage drop. The overcurrent protection device, such as a circuit breaker or fuse, is designed to protect the circuit conductors and equipment from overloads and short circuits. The overcurrent protection device is sized to trip or open the circuit if the current exceeds the ampacity of the conductors or the rating of the equipment. The NEC specifies the maximum allowable overcurrent protection for different types of conductors and equipment. It is essential to select the correct size of overcurrent protection device to provide adequate protection without causing nuisance tripping. In the scenario described, the air conditioning unit has a minimum circuit ampacity rating of 32 amps, which means that the circuit conductors must be capable of carrying at least 32 amps continuously. The air conditioning unit also has a minimum breaker rating of 50 amps, which means that the circuit breaker must be rated to trip at 50 amps or higher to provide adequate protection for the unit. Number 10 THHN wire has an ampacity of 30 amps when installed in accordance with the NEC ampacity tables. This means that number 10 THHN wire is not suitable for use with the air conditioning unit because its ampacity is less than the minimum circuit ampacity rating of the unit. Using number 10 THHN wire in this application would create a fire hazard because the wire could overheat and potentially cause a fire. To safely connect the air conditioning unit, it is necessary to use a larger size of THHN wire that has an ampacity equal to or greater than the minimum circuit ampacity rating of the unit. Number 8 THHN wire has an ampacity of 40 amps, which is sufficient for the air conditioning unit in this case. It is also important to ensure that the circuit breaker is sized appropriately to provide adequate protection for the unit and the conductors. In addition to the NEC, local electrical codes may also have specific requirements for the installation of electrical wiring and equipment. It is essential to consult with a qualified electrician and to comply with all applicable codes and regulations to ensure that the electrical installation is safe and compliant. When working with electrical wiring, it is crucial to take precautions to avoid electrical shock and other hazards. Always to energize the circuit before working on any electrical components, and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to perform the work. To summarize, when connecting an air conditioning unit with a minimum circuit ampacity rating of 32 amps and a minimum breaker rating of 50 amps, it is not safe to use number 10 THHN wire because its ampacity is only 30 amps. A larger size of THHN wire, such as number 8 THHN wire with an ampacity of 40 amps, should be used to ensure that the circuit conductors can safely carry the anticipated load without overheating or causing a fire hazard. Always consult with a qualified electrician and comply with all applicable codes and regulations to ensure that the electrical installation is safe and compliant. When dealing with electrical installations, understanding the National Electrical Code (NEC) is paramount. The NEC provides comprehensive guidelines for safe electrical practices, covering various aspects such as wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to incorporate the latest advancements in electrical technology and address emerging safety concerns. Adherence to the NEC is essential for ensuring the safety of people and property. Article 310.15 of the NEC provides detailed information on conductor ampacity. This article outlines the factors that affect the ampacity of conductors, including conductor size, insulation type, ambient temperature, and the number of conductors in a raceway or cable. The NEC provides ampacity tables that list the allowable ampacities for different types of conductors under various conditions. These tables are used to select the appropriate size of conductors for electrical circuits based on the anticipated load and operating conditions. The NEC also provides correction factors for adjusting the ampacity of conductors based on ambient temperature and the number of conductors in a raceway or cable. These correction factors are used to ensure that the conductors are not overloaded under adverse conditions. Overcurrent protection is another critical aspect of electrical safety covered by the NEC. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the maximum allowable overcurrent protection for different types of conductors and equipment. It is essential to select the correct size of overcurrent protection device to provide adequate protection without causing nuisance tripping. Article 240 of the NEC provides detailed information on overcurrent protection. This article outlines the requirements for selecting and installing overcurrent protection devices, including circuit breakers, fuses, and other protective devices. The NEC also provides guidelines for coordinating overcurrent protection devices to ensure that the device closest to the fault or overload trips first, minimizing the impact on the rest of the electrical system. Grounding is another essential aspect of electrical safety covered by the NEC. Grounding provides a low impedance path for fault current to return to the source, which helps to protect people from electrical shock and equipment from damage. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors, the methods for connecting grounding conductors to equipment, and the requirements for grounding electrodes. Article 250 of the NEC provides detailed information on grounding. This article outlines the requirements for grounding different types of electrical systems, including alternating current (AC) and direct current (DC) systems. The NEC also provides guidelines for grounding sensitive electronic equipment to minimize the risk of electrical noise and interference. In addition to the NEC, local electrical codes may also have specific requirements for electrical installations. It is essential to consult with a qualified electrician and to comply with all applicable codes and regulations to ensure that the electrical installation is safe and compliant. When working with electrical wiring, it is crucial to take precautions to avoid electrical shock and other hazards. Always to energize the circuit before working on any electrical components, and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to perform the work. Considering wire gauge and ampacity, it is essential to consider the distance of the wire run. Longer wire runs result in greater voltage drop, which can affect the performance of electrical equipment. To mitigate voltage drop, it may be necessary to increase the size of the conductors. The NEC provides guidelines for calculating voltage drop in electrical circuits. These guidelines can be used to determine the appropriate size of conductors to minimize voltage drop and ensure that electrical equipment operates correctly. When installing electrical wiring, it is essential to follow the manufacturer's instructions for the wiring devices and equipment being used. Wiring devices, such as receptacles and switches, are designed to be installed in a specific manner to ensure proper operation and safety. Equipment, such as lighting fixtures and appliances, may have specific wiring requirements that must be followed to ensure that the equipment operates correctly and does not pose a safety hazard. Before installing any electrical wiring or equipment, it is essential to inspect the components for any damage or defects. Damaged or defective components should not be installed, as they may pose a safety hazard. When making electrical connections, it is essential to use appropriate connectors and to ensure that the connections are tight and secure. Loose or corroded connections can cause overheating, arcing, and other electrical problems. After completing an electrical installation, it is essential to test the installation to ensure that it is working correctly and that there are no safety hazards. Testing should be performed by a qualified electrician using appropriate test equipment. The NEC requires that all electrical installations be tested to ensure that they meet the requirements of the code. In summary, electrical safety is paramount when working with electrical wiring and equipment. Always follow the NEC and local electrical codes, and take precautions to avoid electrical shock and other hazards. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to perform the work. Understanding the fundamentals of electrical wiring is essential for anyone working with electrical systems. This includes understanding the different types of wiring, the proper methods for connecting wires, and the safety precautions that must be taken to avoid electrical shock and other hazards. Electrical wiring is typically made of copper or aluminum, although copper is the more common material due to its higher conductivity. Wires are available in a variety of sizes, or gauges, with a gauge number indicating the diameter of the wire. Smaller gauge numbers indicate larger diameter wires, which can carry more current. The amount of current that a wire can safely carry is known as its ampacity, which is determined by the wire size, material, and insulation type. It is important to select the correct size of wire for an electrical circuit to ensure that it can safely carry the anticipated load. Overloading a wire can cause it to overheat, which can lead to a fire. The electrical wires are insulated with a variety of materials, including plastic, rubber, and varnish. The insulation protects the wire from damage and prevents electrical current from flowing where it is not intended to flow. Different types of insulation are designed for different applications, with some being more resistant to heat, moisture, or chemicals than others. When selecting electrical wire, it is important to choose a wire with the appropriate insulation type for the intended application. Electrical wires are connected using a variety of methods, including wire connectors, soldering, and crimping. Wire connectors are the most common method for connecting wires, as they are easy to use and provide a secure connection. Soldering is a more permanent method for connecting wires, but it requires specialized equipment and skills. Crimping is another method for connecting wires, and it is often used for connecting wires in automotive and marine applications. When making electrical connections, it is important to ensure that the connections are tight and secure. Loose or corroded connections can cause overheating, arcing, and other electrical problems. Before working on any electrical wiring, it is important to disconnect the power to the circuit. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It is also important to use appropriate safety equipment, such as rubber gloves and safety glasses, to protect yourself from electrical shock and other hazards. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to perform the work. In addition to understanding the fundamentals of electrical wiring, it is also important to be familiar with the National Electrical Code, NEC, which provides guidelines for safe electrical practices. The NEC is updated every 3 years to incorporate the latest advancements in electrical technology and address emerging safety concerns. Adherence to the NEC is essential for ensuring the safety of people and property. Some additional considerations when working with electrical wiring include understanding the different types of electrical circuits, such as branch circuits and feeder circuits. Branch circuits supply power to individual outlets or appliances, while feeder circuits supply power to multiple branch circuits. It is important to select the appropriate size of wire and of a current protection device for each type of circuit to ensure that it can safely carry the anticipated load. Another consideration is understanding the concept of voltage drop, which is the decrease in voltage that occurs as electrical current flows through a wire. Voltage drop could affect the performance of electrical equipment, so it is important to minimize voltage drop by using the correct size of wire and keeping wire runs as short as possible. When installing electrical wiring, it is important to follow all applicable codes and regulations, including local building codes and the NEC. These codes and regulations are designed to ensure the safety of electrical installations and prevent electrical hazards. If you have any questions or concerns about electrical wiring, it is best to consult with a qualified electrician. They can provide expert advice and ensure that your electrical system is safe and up to code. In the context of the original question, the use of number 10 THHN wire with a 32 amp air conditioning unit is a clear violation of electrical safety principles and the NEC. The ampacity of number 10 THHN wire is insufficient for the load, creating a significant risk of overheating, fire, and equipment damage. Upgrading to number 8 THHN wire or larger is essential to ensure the safe and reliable operation of the air conditioning unit.